in the numerator summation of pi into delta I. Yes, any confusion? Any confusion are there? Okay, one just a second. Everybody just note down this. Transfer function C of s divided by R of s for a system is represented by signal this. For a signal flow graph is given by this. C of s divided by R of s, that is equal to summation of pi into delta I, where I will start from 1 and it will end to n. That is 1 to n divided by determinant. Divided by the determinant. Where n is number of forward paths. Then pi is the ith forward path gain. Ith forward path gain. Now what, at this moment you may not understand anything, you just copy this down. Once I'll start solving problem, the things will be clear. Once we start solving problem, the things will be clear. At this moment only just go on noting down these formulas, where n is nothing but the number of forward paths, pi is nothing but the ith forward path gain, delta is the determinant of the system, and delta I is the determinant of the ith forward path. Delta I is the determinant of the ith forward path. Only note down this. Need not note down this. Then I'll explain it later. N is the number of forward paths. Pi is the ith forward path gain. Delta is the determinant of the system. Delta I is the determinant of the ith forward path. Hope everybody has noted down this. Anybody still noting it down? Hope everybody has noted down. Then I'll go to next slide. Now, then just note down this also, where delta is equal to, where delta, how to determine. Now you have seen this, how to determine delta, that is being given here. Delta
Sir,
is, yes, tell me.
So previous slide, sir, delta.
Right.
Yes.
You need not take down this. This I'll just discuss this later. At this moment you may not understand, so simply do not write this. Only you write these four terms, that is n, pi, delta, and delta I. Delta is the determinant of the ith forward path.
Done, sir, done.
Is it done? So then we'll go to this. You must note down this way. This is very important. That is how to find the delta and delta I. Delta is equal to 1 minus sum of all individual loop gains. Delta is equal to 1 minus sum of all individual loop gains. Sum of all individual loop gains plus sum of.
Excuse me, sir.
Tell me. Yes.
Okay, sir.
Tell me. Yes. Any
No,
confusion?
sir. Your presentation was not visible, sir. Now it is visible, sir.
Visible? Visible.
No, sir.
Visible, no?
Yes, sir. Now it is visible, sir.
Okay.
Yes, sir.
Okay. Now there is one methodology of writing this. Here there is one negative sign, there is a positive sign, again there is a negative sign, again there is a positive sign. How to do it? There is one very simple method. I'll just tell you now only. Just observe for a minute. It is 1 minus sum of individual loop gains. Now when it is a odd number, we get a negative sign. Then sum of product of loop gains of possible 2 loops. So when it is 2, it will be positive. So when it is an odd number, it will be negative sign. When it is a even number, it will be a positive sign. Odd number is a negative, even number is positive. Now again here sum of products of loop gains of all the possible 3 loops. So again it is 3, so it's negative, and here it is 4th, so it is positive. So it is 1 minus loop gains of single plus sum of product of loop gains of 2 possible loops. That is when it is 2, it is positive. If there is 3, it is negative. So for odd numbers, it is negative sign. For even numbers, is positive sign. Just remember this. So when we'll solve the problem, that time it will be clear. But just note down this. It is sum of all individual loop gains plus sum of the product of the gains of all possible two loops that do not touch each other. This is very important statement. Sum of the product of the gains of all possible two loops that do not touch each other. Don't get this. Already we have discussed this in the previous problems, so it is only here we are mixing one or two other steps and finding. Most of the things is already known to you. So since you have discussed this problem there, you know it. Only you are substituting the previous things what you have found. Only you are substituting this in formula and trying to find the answer. Rest all things are very simple, don't worry. Then it is sum of the product.
Sir, your voice is breaking, sir.
One minute. Is it clear now? Just observe. Is it clear?
So it is clear,
Okay,
sir.
okay.
Excuse me, sir.
Yes, some problem, I think.
One minute. Is it clear? Hope it is clear. Okay. Okay, I'll just maximize this. Okay. It is sum of the product of the gains of all the possible 3 loops that do not touch each other. It is sum of the product of the gains of all possible 3 loops that do not touch each other. Plus so on. You write so on. Because usually in terms of problems, no, we only most of the times we only reach this 1 minus plus minus. So up to 3 loops only we do. We don't usually go for the 4th loop. That becomes if there is a very, very complex problem, then only we'll go for this. But even then, you just note it down this. You may also note down that delta I. And as far as portion is concerned, portion is already put up in that main group, that is ABCD, which was the earlier thing in that put up. That is unit number 1, introduction, mathematical models and analogy. And in unit number 2, we have block diagrams. Then as far as the presentations or material is concerned, material is when the soft copy is already one textbook is given to you through one group, that is your unofficial group. And regarding PPTs have been already put up in that central group. Just check out. I have put up the introduction and mathematical modeling. Analogy also is put up. Even block diagram and even this PPT, whatever we're discussing today, even this is also put up. In unit number 1, you will find 2 presentations. And in unit number 2, you will find two more presentations. Now, that is one of block diagram and signal flow graph. But remember, signal flow graph, whatever we're discussing today, is not there for IA. Only block diagrams, whatever we have discussed in previous things, are there. Okay, hope you have noted down this. Okay, we'll go to one problem. So once we start problem, then only we'll understand this. Otherwise, whatever if I tell now something you may not understand. So once having understood, then once again I'll come and explain that formula so that you'll understand. Now, for this, what you do is you just take down this simple signal flow graph. You take down this very simple signal flow graph. Then for this, we'll apply that Mason's rule. Then we'll understand the problem. Then we'll go ahead with the slightly complex problems. Now just take down this. And whenever you are noting it down, remember, whenever these nodes are there, you number them by the digits. Like this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So note down these numbers. So that numbering is very much necessary. Numbering is very much necessary. And why that numbering is necessary, that will just tell you now. Why that numbering is necessary, I'll just tell it now. You just note down the signal flow graph and put the numbers. And here, whenever in the problem, apply the Mason's rule formula and solve the signal flow graph, then only you'll have to solve this. Or else, sometimes a question is asked that given a signal flow graph, identify the following, what we had discussed in the previous class. So that can be one of the questions. Hope you have noted down, everybody's noted down this. So what I'll do is I'll start with the problem. Now, see here, what is the first and the foremost thing? First and the foremost thing is, first identify how many number of forward paths are there. So if you just observe, there is one forward path, which I'll just tell you, that is 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. Now, don't tell me that these numbers are not there. That is the reason I have told, please, wherever the nodes are there, you just identify them by the numbers. So this is one node, this is second node, this is third node, this is fourth node, this is fifth node, and this one is sixth node. You'll have to just practice like Rangoli, what at home they do. Similarly, like first you'll have to go on putting the dots, then only go on joining the this. So the dots should be prominently seen. Don't put a very simple dot which cannot be seen. Dots should be prominently seen. So just put a number that 1, 2, 3, 4, 5, and 6. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6 is your first forward path. Then the second forward path is 1 to 2, 2 to 3, 3 to 4, not like this, but opposite. Means we are allowed to just cross this. So 2 to 3, 3 to 4, sorry, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. So one is the straight path, and one more is this path, which is going to take along the G3. That is what is there. See, so there are two forward paths. What you can do is, do not write P1 and P2. Instead, write F1 and F2. I'll just tell you, write F1 and F2. F1 is the first forward path. F2 is the second forward path. So henceforth, remember, notation for forward path, you can write F1, F2. Subscript, not superscript, subscript, like this. Do not write superscript, or neither write sideways. So remember, all in the signal flow graph, it is a subscript. Means what is subscript? At the bottom. This should come at the bottom here, not raised to. That is F1 is equal to G1, G2, G4. That is G1, G4, and G2. This is the first forward path. And second forward path is G1, G3, and G4. G1, G3, G4 is nothing but like this. So this is the first forward.
So we can also use T1, no sir?
Which one? Tell me.
T sir, T. T for tongue, sir.
Which one for this? No.
P sir, instead of P.
No. You allowed to use F forward path. F, capital F.
Okay, sir.
Because that is one standard notation which they follow. So you write F, capital F, as the forward paths. Okay. Now, once that is done, having noted down this, now this is the formula that we had seen in the previous slide. That was Mason's gear formula is C by R is equal to summation of Pi delta I divided by delta, where summation is from I is equal to 1 to n. Now, how did we come across this? Remember, how many forward paths are there? That many number of this will come. So what you can write? F1 delta 1 plus F2 delta 2, or this way you can write. So this is nothing but the formula. This is the formula. Got it? So this one is the formula. Is it clear? Have you understood why? Because there are only two forward paths. So in the numerator, there will be only two things which are going to appear. And in the denominator, we have a delta. Is it clear? Understood how to do this? If there were three forward paths, F1 delta 1, F2 delta 2, F3 delta 3, or P1 delta 1, P2 delta 2, P2 delta 3. See here again, there is no hard and fast rule that you'll have to use F1 or P1. Only the concept you'll understand. If somebody is using P1 and solving it, no problem. I'm making it quite clear. If somebody is using P1 and writing this in the formula, no problem. If they are using F1, also no problem. Understand is, concept wise, this problem should be correct. That is the basic idea. Is it clear? So you can use this P as also if you want, if you're finding it easy for forward path F, that is also okay. There is no hard and fast rule that I allow to use either F or P. I'm making it quite clear. Okay. Now in this case, I'll use this P1 delta 1 plus P2 delta 2. Why? Because there are two forward paths. That is, this is one, therefore this. So P1 delta 1 plus P2 delta 3. If there are two more forward paths, I'm just giving an example. If there are four forward paths, then it will be P3 delta 3 plus P4 delta 4 divided by 4. So this is the second step. Once this is done, what you'll have to find is, Next, we'll have to find the number of loops. So first and the foremost thing is, whenever a signal flow graph is been asked to solve with help of the Mason's formula, first draw the drawing. Once the drawing is drawn, put the numbers onto the put the numbers. Now here one more thing, before going forward, here if you are finding it difficult to identify this, you will have to use this method. I'll just show you that this method. Prefer to go with this method. See here, now see here, as in this case, what have they done? They have, see here, now in this case, they have identified this forward path. So if you're finding it easier, so what you do is you draw this forward path and write is F1 or P1 is this, because what you just draw this draw this drawing, so that there will be no confusion. Because if the problem is very complex, in that there is all possibility that you might miss one forward path. So don't go with directly with help of this. What you do is you just trace the signal flow graph starting from the input node to the output node, or from the source to sink, and draw this one simple drawing. So in this case, in this problem, how are you going to do it? I'll just show you. Just a second. In this case, what we are going to do is we are going to write P1, G1, G4, G4. What you do is 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. You draw one single straight line beside this. Second, P2 is equal to 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. If you do this, then even if you make mistake here, since the drawing is correct, you will be awarded marks. Remember, because if you are making mistake in identifying the forward paths, then the whole problem is going to get wrong. Remember this. So in order to simplify this, even if the problem is very simple, you follow this method. So instead of assuming that I'll know, what you do is prefer to make this right, and beside only you draw the drawing. So that it will take half a second, but that will, whatever doubts are there, that will be cleared. So you'll have to use this method for even forward paths as well as for the loops. So what you do is, forward path is this. So draw a drawing. How is the forward path? Very simple drawing. No, not of the same size. Even a small size is also okay, but draw this drawing. Similarly, P2, like this you draw 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. You draw this drawing. So that will be a second. Is it clear? Hope this point is clear. Whether I have made it quite clear, understood? Why is that necessary? Reason is, in case if the complex problems, once we go for the next problem, you'll understand why is that much necessary. Is it clear? Hope, is it clear? Any doubts are there?
No, sir. No,
Sir,
sir.
sir, in this problem, we have taken like P1 and P2, like G2, G1, G2, G4. These are the gains, no, sir?
These are the gains. These are the gains.
Means we have written forward path gains.
Forward path gains only. In this earlier, why was that not mixed? Because you are understanding it, no? You are just studying it. That is the reason I did not say forward path gains. But henceforth, whatever you are allowed to write, you are not going to consider the forward path numbering. You are going to directly write the forward path gains. Is it clear? Because
Yes,
since
sir.
you are studying those yesterday, if I directly start you to write the forward path gain, then that would have been created a confusion. For that reason, initially we wrote only forward paths, then later on we wrote the forward path gain. But henceforth, do not write the forward path, directly write the forward path gain. That will be considered as this. So here you draw the drawings. Now, once this is done, first step is what? First step is identify the forward path. Then write the formula for the Mason gain formula according to the number of forward paths. So as there are two forward paths, P1 delta 1, P2 delta 2 divided by delta. So this is the modified formula, or the formula as per your problem. Then once this is done, then identify the number of loops. Identify the number of loops which are there. So if you just observe here, this is one loop, that is 2 to 3, 3 to 4. This one is one drawing. So you have to draw this. So this is one loop. Then which can be another loop, that is minus G1, G2, G4, H2. So what is this? -1 minus, so this will be here. Just observe here, G1, G2, G1, G4, G2, and this. So this bigger sector, this is the second loop. This one is the second loop. So it is G1, G4, G2. That is what is written here. Minus and is taken out. G1 minus G2, sorry, minus G1, G2, G4, and H2. So this is the second loop. Then what is the third loop? The third loop is G1, G3, G4, H2. G1, G3, see here, just observe here how it is. This will start from 2 to 3, 3 to 4, 4 to 5, then 5 to 6. Understood this? G1, G1, G2, sorry, G1, G4, this part, this forward path, then I'll just traverse this. I'll go here, and then again I come back. What I'll do is, I'll just show you. One minute. Is it understood? Is it clear? Have you observed this? Is it clear, or any doubts are there?
No, sir, no doubt.
Okay. 1 minute. I'll just show that. So, one forward path was like this. One loop was like this. This is one more loop. One more loop was like this. This was one more loop. And the third loop was like this. This was the third loop. So, what we'll have to do is, just a second. Even I'm just trying this. So, here, having written this, what you'll have to do is just below this. So, this is one loop. The second loop is this. Third loop is this. Is it written? Is it clearly understood? Then, once we have understood forward paths, then loops. Now, we will go with the next part. Now let us consider the second part of the problem. So here, if you just observe here, first is, in this problem, if you just observe number of forward paths that are been determined. Then once the forward paths are done, then you have written this. Then in order to determine the delta, I am worried about what? The number of loops. So you have already taken the number of loops. But there is one more part. What is that? That is, you'll have to take two loops together, taking two loops together such that the two loops are non-touching. What do you mean by non-touching? Non-touching means what? They should not have a common node between them. Just observe this. This is one loop, and one more loop is this. In whatever condition is there, there are no two loops which are non-touching. All the loops are touching. Why? Because if you just see G1, G4 term, G1, G4 term, G1, G4 term, is it seen in all the loops? If there are same gain is seen between the two, means they are touching. Just observe here. Or we'll not worry about that way. I'll put it like this. Just observe here. Now, what was the first thing? First was your, or just I'll write, this is 2, this is 3, this is 4. Since I'm writing with this mouse, it is slightly difficult, but just understand this. Now, here, just observe here. Now, loop 1, it is 2, 3, 2, 2, 3, 2. So you are using this is the first loop. Then what is the second loop? It is 2, 3, 4, 5, and 2. So again, 2 is common. So since 2 is common between the two, these two loops are non-touching. They are not touching. I cannot consider them. They are touching. Here in this present case, they are touching. So I cannot consider them as the two non-touching loops. Why? Because they have the common nodes. Then what I'll do is, I'll consider L1 and L3. Now, what is L1 and L3? L1 is 2, 3, 2, 2, 3, 2. Then this 2, 3, 4, 5, and 2. So again, in this, there is in this condition, the 2 is associated. So I cannot consider neither L1, L2, L1, L3. Now, then what we'll do is, we'll consider L2 and L3. Now, if we just observe L2 and L3, again, the nodes are common. So in this condition, there are no two loops which are taken in a pair which are non-touching. All the loops are touching. So in this condition, the value of delta will be 0. Just I'll tell you, the value of delta will be 0. So just observe here. Have you understood this? What is the value? Have you understood this? I'll just show you this. Observe here. See here. Delta 1 is sum of all individual loop gains that we have taken into consideration, which are not touching. So one minute, before going to this step, is there any confusion pertaining to this? Is there any confusion pertaining to this step? Just a second. Have you understood this up to here? Have you understood up to here? Have you
Yes,
understood?
sir.
Okay, you have understood up to here. Then there are no non-touching loops. There are no non-touching loops. Hence, delta is equal to only this term. Why? Because here plus sum of all the non-touching loops taken together, that is not there, and third is also not there. So in this condition, this formula, sum of the products of the loop gains of two possible loops that does not touch each other, this is 0. Similarly, sum of products of the gains of all possible three loops do not touch each other, this is also 0. So in this formula, delta 1 minus sum of individual loop is only existing. This term, that is this part, this entire part, and this entire part, they are 0. This is 0 and this one is 0. Only this is existing. So as this is only existing, so in this consider as these two are 0, we cannot as this only these are existing. So here delta is equal to 1 minus sum of all individual loop gains. Is it clear? Have you understood this delta? How this varies? So this is equal to 1 minus L1 plus L2 plus L3, that is equal to 1 minus. So once we have found out the delta, so in this case, what all things are known to us? We know P1, we know P2, we know delta. But next is we'll have to find delta 1 and delta 2. Now, 1 minute, I'll just slowly come back. So if we just here, P1 value is known to us, P2 value is known to us, then we know delta. Why? Because delta is nothing but 1 minus sum of individual loop gains that is there plus sum of product of loop gains, two loops taken into consideration which are not touching, but that is not available, so that is 0. Similarly, minus sum of three loops taken into consideration which are not touching, again that is not possible. So this formula is only this, so it is 1 minus delta. So we know the sum of individual loop gains that I have written here, 1 minus L1 plus L2 plus L3. So this is my delta. So if we just consider in this formula, I know P1, I know delta P1, P2, I know delta is also know. My next term is to find delta 1 and delta 2, that we are going to find. Now how to find delta 1 and delta 2? Delta 1 and delta 2, what is written here in this formula I just told you. Delta 1 is the value of the delta for the part of the block diagram or the signal flow graph that does not touch the forward path. Means what? It is nothing but the value of the delta. It is nothing but the value of that loop which does not touch the forward path. But all the loops since are lying on the forward path, again this value of delta 1 is only 1, because here there are no loops which are not touching this forward path, because which is a forward path we have taken, this is a forward path, and since all the loops are lying on this forward path, this value is 0. So we have got delta 1. Similarly, considering the second forward path, this is the second forward path. In this condition also, there is no loop which is not lying on this. All the loops are lying on this. So again, the sum of individual loop gains which does not touch that forward path is again 0. So delta 1 is 1 and delta 2 is 1. So what we do is we know that P1 delta 1 plus P2 delta 2 divided by delta. So we have substituted here. P1 is known to us, P2 is known to us, and delta is there. So this is the answer. Is there any confusion related to this problem? Is there any confusion? Yes, any doubts? Do you have any doubts here?
No, sir.
Is it clear?
No, sir. No, sir.
Okay.
Yes,
So,
sir.
what I'll do is, I'll go with one more problem. So I'll just repeat this problem for everybody's benefit once again, so that you will understand. So whenever a problem is given, related to signal flow graph and solve it by the Mason's gain formula. First and the foremost thing what you'll have to do is you'll have to identify the forward paths. So first step is that identify the forward paths that we have done it. So and remember what I have told, wherever the condition is given, please draw the first and foremost thing is first for all the nodes do the numbering. Once the numbering is done, second step is that whenever you are finding the forward path, just draw that figure sidewise so that there will be no confusion. And in case even if you are making mistake here, since you have drawn the drawing, the marks will not be deducted. Second, this is the second forward path. Once you have identify, rewrite or modify the Mason's gain formula as per the problem. So since there are two forward paths, we have P1 delta 1 plus P2 delta 2 divided by delta. If there would have been 4, we would have got P1 delta P3 delta 3 plus P4 delta 4. But as in come across this. Then once this is done, the then next part is we'll have to find the number of loops which are present in the system. So as in this present case, there are 3 loops. Directly write the loop gains which are available. So once this is done, now if you just observe here, my next activity is to find the value of delta. What is the value of delta? Value of delta is nothing but first is sum of all the individual loop gains plus sum of two loops taken into consideration which are non-touching. As in this present case, all the loops are touching one another, so the further values of the formula are all 0. So it will be 1 minus sum of all individual loop gains, that is 1 minus L1 plus L2 plus L3. So directly substitute, you have got the delta. Then similarly, what is delta 1? How to find the delta 1? Delta 1 is nothing but taking the forward path 1, just check which of the loop is not touching that forward path. All the loops since are lying on the forward path 1, this value will be 0. This value will be 0. Similarly, take the second forward path and try to identify which loop does not touch that second forward path. Again, since the loops are lying on this forward path 2, so again this term is 0. So we got that delta 1 is equal to 1, delta 2 is equal to 1. Directly substitute those values in this and we get P1 delta 1, because delta 1 and delta 2 are 1. Directly I am writing P1 value, P2 value, and determinant value is already determined. You write this. This is the whatever I'm going to. So I'll give a break of 10 minutes. I'll give a break of 10 minutes. In the meantime, what you do is slightly come early, then copy it on that problem. Just you can take a break of 5-10 minutes. Okay, we'll start with the class. So this is the second problem. You can just take down everybody. On just a second, just a second. I'll put it in the screen. Okay, is this visible to everybody? Is the screen visible?
Yes,
Yes,
sir.
yes. Okay, take down.
Yes, sir.
Huh?
Yes.
Visible, no? Okay. It is similar like what some kind of rangoli it is. Just similar things are there. Similar. Okay. Oh, I hope you have noted down. Just see what is the first part. First step, as we know that we need to first identify what are the forward paths. So there are two forward paths. One G1, G2, G3, G4. This is one. G5, G6, G7, G8. This is the second forward path. Just observe here, like this it is. Path number one is this. One is of red color, that is path number one. Second is of blue color, that is path number two. This is the first forward path. This is the second forward path. So then how many loops are there? There are four loops. Which are those loops? This is L1, this is L2, this is L3 and L4. So here, so if I start naming 1, 2, 3, 4, 5, 6, 7, 8, just like when one in clockwise, 1, 2, 3, 4, 5, 6, 7, 8. So it will be 2, 3, 2, 3, 4, 3, then 1, 2, 3, 4, 5, 6. Okay. Then here we have this loop and this loop. So there are how many games? So there are totally four loops. Just observe this. So there are four loops. Then here there is one. Hope everybody has observed this. Is it clear? Anybody is there? Any confusion with respect to first things? Yes. Any doubt? Hope I'm audible and clear. Am I audible to everybody?
Yes, sir. Yes, sir. Yes, sir.
Okay, okay. So there are four forward paths. Then there are four loop gains. Now, if you just observe, here we'll have that second condition when taking two loops together which are not touching. So that is possible. Just see here. If I take L1, L3 and L4 are here. Just see here. L1 and L3. L1 and L3 are the two loops which are not touching. Then L1 and L4. This is second pair. Then L2 and L3. Then L2 and L4. 1, 2, 3, 4, 1, 2, 3, 4. So there are four loops taken two at a time which are not touching. So just see, if I take L1 and L3, these are two loops taken together which are not touching. L1 and L4 are the again other two loops which are not touching. Similarly, L2 and L3 again are the two loops which are not touching, taken two at a time. L2 and L4 are the two loops which are not touching, taken two at a time. But we don't have the third option, that is three loop taken together which are not touching. No, I cannot take, because L1 and L2 or this, any if I take one or the other condition is touching. So I will have to end here only. Consider two non-touching loops. This pair, this pair, this pair, and this pair. So there are totally 4 pairs of two non-touching loops. But there are no 3 non-touching loops. Why? Because if I take L1, L2, L3, again L1 and L2 is joining. Then if I take L1, L2, and L3, no, again I cannot take. Again, L3, L4 this. So if whatever permutation combination I do, I cannot have this third condition, that is 3 non-touching loops is not possible. So I will have only condition 2 non-touching loops which are possible are only 4 pairs. Hope this is clear. Have you understood this? Any doubts? Is it clear? Then next we will go to this. Calculate the delta. What is delta? Delta is nothing but 1 minus sum of the loop gains of all the forward paths. Sum of the loop gains of all forward paths. Sum of all the loop gains. Sum of all the loop gains, not the forward paths. Sum of the all loop gains plus loop gains of those 2 non-touching loops. Sum of the loop gains of 2 non-touching loops taken in a pair. So again we have this. These what are these? These are the thing what 4 L1, L3, L1, L4, L2, L4, L4. This you just take down and multiply this. So we get this. So this is the delta. Is it clear? Have you understood the step number 5? Is it clear with respect to step number 5? Are there any confusions? Yes, any confusion are there with respect to step number 5? Let me know. Any confusions? Yes, any confusions are there? I hope you noted down and
No, sir.
No? Okay. Okay.
No doubts.
Yes, sir.
Okay. So now this is the condition. Then next what we'll do is we'll go to the next step, that is what is calculate the delta 1. So first for what is the first, this is the forward path. Now which was this forward path, this why is this? Because if I take forward path number 1, which was the first which was our forward path, this is a red color which was there. So if I consider red color as a forward path, these two are those 2 loops which are not touching the forward path number 1. So it will be delta 1 minus L1 and L4. That is what is shown. Similarly, when I take this blue color forward path, L1 and L2 are not touching. That is what is shown in this problem. Just consider. So which is the forward path? Forward path is G1, G2, G4, G3 and G4. If I consider this forward path, in this condition, this loop and this loop are not touching. That is considered here. So it is the loop gain of all these 2. So 1 minus L1 plus L3. Why? Because this. Similarly, if I consider second forward path, if I consider this second forward path, in this condition, L1 and L2 are not touching. So this, it is be L1 minus L2. Now just observe here, in this eliminating of the first, eliminate the forward path number 1. So which was the forward path number 1 was this. This was the forward path. In this case, when I consider this forward path, L3 and L4 are not touching. Since L3 and L4 are not touching, delta 1 is equal to 1 minus loop gains of those loops which are not touching that forward path. So that is what is shown here. So if I consider loop number 1 or the forward path number 1, loop number 3 and loop number 4 are those 2 loops which are not touching the forward path, or they are not lying on that forward path. So that delta 1 will be equal to 1 minus summation of the loop gains of those forward paths, or the loop gains of those loops which are not touching that path. That is what is written here, L3 plus L4. Similarly, forward path number 2, in this condition, if I consider this forward path, that is second forward path, that is G5, G6, G7 and G8. In this condition, L1 and L2 are not touching. So it will be delta 2 is equal to 1 minus loop gains of L1 plus L2. Loop gains of L1 plus L2, that is what is written. Loop gains of L1 plus L2. Is it clear? Hope this point is clear. Is it understood? So having understood this, having just this, what we'll have to do is P1 delta 1 plus P2 delta 2 divided by delta. So this is very big. I try to minimize it, but it is not fitting. Let's write down. What is this? L1, you have found out the delta value. You write in the denominator. write in the denominator. P1 value is there, delta 1 you write, plus P2 value is there, you write delta 2. P1 delta 1 plus P2 delta 2 divided by delta. Is it clear? Is it clear? You can mark this problem. This problem is very important. Usually, most of the time, this problem was asked. You can just mark this problem. Very important. Yes. Any doubts with respect to this problem? Let me know. If you have any doubts, let me know. I'll just clarify it. Or else we'll go to the next problem. Any doubts are there? Yes. Any doubts?
No, sir. No, sir.
So values of delta 1, delta 2, can you show one more time?
Okay. Okay. It's here. What is delta 1? Delta 1 is nothing but consider that forward path, as in this case of forward path number 1. That is what is forward path, that is G1, G2, G3 and G4. If this is the forward path, this is the forward path. To this, L3 and L4 are not touching. So 1 minus L3 plus L4 are taken into consideration. Similarly, when I consider forward path number 2, that is this. In this condition, L1 and L2 are not touching. So what I'll have to do is, I'll have to write 1 minus the loop gains of those loops which are not touching that forward path. So that is written here. So first forward path, L3 and L4 are not touching. So for the second forward path, L1 and L2 are not touching. So we have substituted this. We have got this value, that is delta 1 and delta 2. Only directly substitute this because we know P1 value known, P2 value is known. Then delta 1 and delta 2 we have found out. In the previous slide, we had found out the delta. What was the delta? Delta is nothing but 1 minus summation of all the loop gains plus summation of all the loop gains of two non-touching loops. That is this that we have taken into consideration, and having found out all the values, only directly substitute it here, and we have got this final answer. This is the final answer. Is it clear? Any doubts? Any doubts?
No doubt. No
Okay.
doubt.
Okay. Okay. Just take down this problem once. You can take down this one more problem. Okay, note down this problem. This is one more important problem. Okay, have you noted down this problem, everybody? Just a second.
Yes, sir.
Okay. Piyush Kudolkar, have you noted down this? Prasad Bandekar. Yes, have you noted down the problem? Prem Kumar Dodgaudar, have you noted down?
Yes, sir.
Okay, okay. Here, I request everybody to slightly give your answers, because may not know how many of you have noted or how many of you understood. For that reason, I randomly ask the names. There is nothing I want to check whether you are present or no. Basically, what I want is whether it has understood or no. For that is the reason. So here, now if we just observe this problem, here, how many number of forward paths are there? There is only one forward path. How to identify? See here, there is one simple method. We first go on putting the numbers. So this is node number 1, 2, 3, 4, 5, 6, 7, and 8. First I go on putting the numbers. So once this number is done, I'll start from input to output. So if you just see here, this is my input node, this is the output node. So this is the first forward path, that is 1, 2, 3, 4, 5, 6, that is G1, G2, G3, G4, and G5. Then apart from this, is there any other? No, there is only one forward path, that is this, that is P1, that is what is shown in the red color. So there is only one forward path. There is no other forward path except this, that is P1 is the only. So what you are going to get, C by R is equal to P1 delta 1 divided by delta. That is the problem. So P1, so C by R is equal to P1 delta 1. Now, have you understood this? Any doubts? Now, once this is done, what is the second step? We'll have to find the number of loops. So this is one loop here, just G1, H1, G4, H2. Then there is one more loop, that is G2, G3, G4, G5, G6, G7, G8. So this is the bigger loop. This is one more loop. That is what is shown here. If you just observe here. So first loop is what? G1, H1, sorry, G2, H1. G2, H1 is first. Then G4, H2 is the second. G4, H2 is the second. Then third is G7, H4. G7, H4 is the third. Then this bigger loop, that is G2, G3, G4, G5, G6, G7, G8. So this is the fourth loop. So how many we have? We have 4 number of loops. So we have totally 4 number of loops. So next, what is the next condition? We'll have to go with that. Find the 2 non-touching loops. So if I consider L1 and L2, yes, L1 and L2 can be taken because L1 and L2 are those 2 loops which are not touching one another. So L1 and L2 pair can be done. Similarly, L1 and L3 is also possible. L1 and L3 is also possible because they are not having the same common nodes. Similarly, L2 and L3. So L1, L2, L1, L3, and L2, L3. So if you just see, there are 3 non-touching loop pairs. That is what is consideration. L1, L2, then L1, L3, and L2, L3. So these are the 3 pairs of 2 non-touching loops taken 2 at a time. So there are 3 pairs, first, second, and third pair of 2 non-touching loops. 2 non-touching loops taken at a time. Similarly, we have one more. 2 non-touching loops taken 3 at a time. 2 non-touching loops, that is non-touching loops. Non-touching loops, if we just here statement this, non-touching loops taken 2 at a time. Non-touching loops which taken 2 at a time. Similarly, non-touching loops taken 3 at a time. So if we just here L1, L2, and L3 again are those non-touching loops which are not touching this. So just observe here L1, L2, and L3. So again, this is the condition. Hope this is clear. Any doubts are there with respect to this? L1, L2, and L3. L1, L2, L3. Are there any doubts? Any doubts are there here? Because in the previous problem, we had only the condition of L1, L2, L1, L3, and this. But here, when taking non-touching loops taken 3 at a time, this is possible here. This is possible. So we can take that. Then next, what is the condition? We'll have to find the delta. What is the delta? Delta is very simple. Delta is 1 minus loop gains of all the forward paths, or sorry, loop gains of all the loops which are present. So there are how many loops? L1, L2, L3, L4. That is what is written here. This is L1, this is L2, this is L3, and this is L4, plus L1, L2, L1, L3, L2, L3. So that is written here. So this is L1, L2, this is L1, L3, this is L2, L3. So that is taken minus L1, L2, L3. Minus L1, L2, L3. That is the reason what I told. If there are odd numbers, we have negative sign. If there are even numbers, there is a positive sign. Because here we have taken non-touching loops taken 2 at a time. Here non-touching loops taken 3 at a time. Since there is 3, it is an odd number, we are negative sign. These are the loops of individual loops, that is positive sign, and these are the loops of, that is non-touching loops taken 2 at a time, that is what is the positive sign. So once this is done, so what we have found, P1, we have found out, we have found the delta. Now we'll have to find the delta 1. Delta 1 is very easy, because why? Because we know that L1, L2 and L4 are not possible, because they are lying on the forward path, because they have the common nodes. Except L3, all other loops are lying on the forward path. So the delta 1 is equal to 1 minus L3, that is G7H4, that is minus G7H4. Only substitute this in the final value, because here this is the forward path, this is the only the eliminating. So substitute this value in the final answer, that is P1 value substitute, delta 1 is substitute, right, divided by delta. Now see here, if you are unable to write this entire thing once again, you can only write delta, because already you mentioned delta value somewhere. So you can write this equation as some value, and for this make sure that you do not make any mistake here. You do not make any mistake here. With this, just observe what was the value of P1. For the P1 value, it's G1, G2, G3, G4, G5. So answer will be what? G1, G2, G3, G4, G5 into 1 minus G7H4 divided by delta. Divided by delta is the final answer of the signal flow graph. Final answer of the signal flow graph. Yes. Any doubts? Any doubts are there? Yes, let me know. If you have any doubts,
No doubt.
okay. Yes, any doubts?
So for forward path,
Tell me.
so can we consider G1, G2, G3, G4, G5, G6, G7, G8 again and go back?
No.
Or only
Because
straight line?
there is a return with signal. What I'm saying is, what is a forward path? Forward path is nothing but that path where there will be no kind of feedback, no backward
Okay,
feedback. So this cannot be forward path. Or this is only forward path. And one more thing, in case of forward path, important is the two ends will remain constant. So it will be nothing but a connection between that is the input node and the output node. Always the flow has to flow from input node to output node. There cannot be, it cannot stop at any intermediate point. It has to end at that point only. So that is a forward path. Got it?
Yes, sir.
You cannot stop intermediate anywhere, and you cannot counter forward path. So if you start at the input, you'll have to go to output, then only it is called as a forward path. Now, next what you do is, you just copy down this problem, and try to give us try to solve it. So with that, we'll conclude today's class. You just copy down this problem and try to solve at home. Next class, we'll solve this problem, because this will take slightly more time. So you just note down this problem, and with that, we'll conclude. Only note down this problem. Here I have given some hint. That is what, there are 3 forward paths. Which are those 3 forward paths you'll have to identify. And there are so many number of loops. This problem, if it comes, it will be for at least minimum 12 to 15 marks, because it is slightly bigger problem compared to the others. Previous problems were much easier. As easier in sense, even this is easier, but here a number of loops are slightly larger, and iteration. So the value whatever you're going to get in as answer, it will be slightly bigger. And remember one thing, suffix these numbers, whatever you are putting, put it properly, because sometimes we have seen that students don't put that number, and there is a mistake, and in that possibility there are marks which have been cut. Make sure that all whatever
Sir, can you show the answer to the last problem, sir?
Okay.
Excuse me, sir.
Sorry, sorry. Okay. Tell me. Okay.
Sir, the answer to the last question, sir.
1 minute. Last is I have not written the answer because this was not getting fitting in this slide. So what it is, P1 numerator will be G1, G2, G3, G4, G5 into this delta 1 divided by this value. Getting it? Because
Okay,
what
sir.
is the P1? Forward path is this G1, G2, G3, G4, and G5. This is the forward path into delta 1. This is the
Yes.
this divided by this value. Getting it? So since this was not fitting, I have not written. Just because all the terms are already here, I thought we would directly write. So in case of exam, you write this. So for final answer will be G1, G2, G3, G4, G5 into delta 1. This is what? That is P1 delta 1 whole divided by delta. There is no need to write two times value of delta, because if you have written somewhere in the numerator or somewhere in the earlier thing, that can be considered. Okay. So you try to solve this problem at home. Just see, try to give a just try it, you try to do it. In the next class, we'll solve this. Is it done?
Yes, sir. Yes, sir.
Okay. Before concluding, once again, I'm going to this. That is coming Monday. That is 19th afternoon. 2:30 to 3:45 hour is your control exam. The portion for the test is introductory part. That is, what are control systems, open loop control system, closed loop control system, difference between that, idle characteristics. Then few standard examples which I had seen in the this where in we had example of missile launcher and some examples we had seen. Those are there. Then mathematical modeling is there, where we are considered that spring damper and mass systems and problems pertaining to that. Then problems pertaining to analogy, current and voltage. That is what is there in chapter number 1. In chapter number 2, we have block diagrams. So this is the portion for IA. If you have any doubts or pertaining to IA portion, let me know so that I will clarify, because we may not be meeting officially till almost 15 days. After 15 days only we'll be meeting, because next week is your IA. So I do not know. Okay, one more thing. Next Thursday, I think there is no IA. Whether you are whether you'll be attending the class or how? Let me know.
Just studying, sir, for IS next time.
Studying for
Probably,
IA,
sir.
you will not be attending the
Yes,
class.
sir.
Okay. That
Yes, sir, mostly.
okay. That will let me know. Okay.
So, and
Okay, sir.
Tell me.
so for IA, the Proctor type exam is there. So where will the link sent, sir?
No, everything link will be sent to you. Only what that it is already prepared. It will be sent to you by a day or two to your group, or I'll just confirm, because what they're doing is they're
Link
confirming.
is sent, sir.
It is already sent.
So link is sent.
Yes, sir. They have made batches, no, sir.
Okay, batches, everything is done. Okay, and your I think even the roll numbers, USN numbers are also done. Just check out.
Okay, okay, sir.
Yes,
Make
sir.
sure
According to
that
batches.
one more thing. Whatever things you are writing, please preserve the documents. That is, wherever you are writing, once after scanning, don't throw those pages out, because later on you might be required to submit those copies. So if you have any book, 100 pages or 200 pages book, prefer to write those IAs in that book only and maintain that. Like similarly, how your IAP books are there. If somebody is coming to college, you can take that copy, or else outside also, if you is there, you can just take the copy and maintain that copy with you, and that pages only you can go on scanning.
Okay, sir.
Okay, then one more thing, there are few instructions which I would like to tell you is, first and the foremost thing is, during proctored exam which is there, try to maintain, when suppose you are sitting in front of the camera, and see that there is proper gap between you and camera, so that the examiner can see it. That is the first thing. And whatever writing materials you want, including your ID card, everything should be there in front of you, as if you are attending an exam. All the documents, pen, pencil, rubber, calculator, everything should be there. Once you are sitting in front of this exam, you are not supposed to move. That is the first thing. Got it? Is it clear? Then one more thing is, once you have scanned the document and send, once till the confirmation is given by the examiner that they have received, don't quit the exam. Don't come out of the exam. Is it clear? Once the confirmation is given by the examiner that your paper has been received, till then don't come out of the exam, and maintain that. And one more thing, declaration. There is one more declaration, that one declaration form, I think, is you have received, is it?
Yes, sir.
What you do is, everybody prepare declaration earlier only. Don't you prepare one Word document, in that all the details you type it, and you know which papers you are attending. All the papers you type it, sign it only, and even the dates are also there. You prepare those declaration well in advance, and only go. You need to keep this thing scanned and sent. Are you getting it? Don't on the day of exam go on preparing this declaration.
Yes, sir.
Because all the things are common. Your name, address, everything is common. Then what is the other reason? Why keep on doing the declaration on the day? Prepare that and scan it properly. And one more, while scanning, keep as a single copy. Don't send it as an individual copy. Scan it properly and send it.
So the declaration must be sent with the paper or after
Sir,
that?
Earlier, before starting exam, they ask you the declaration. Then I think they'll ask you the papers.
Yes, sir.
Okay.
Sir, declaration should be hard copy, sir.
No, soft copy, man. Soft copy only. How are you going to send hard copy?
So in the instructions, they have given that the form should be hand-filled.
Hand-filled? No, even if that hand-filled, but even if the things are made ready, that I'm saying, you make it hard copy or just whatever. But well in advance, if you do it, then because already you know which exams you are attending. If that is done by you, there is on that day of exam, once paper is received, you start writing. That is what I'm saying. Getting it? And
So just upload the soft copy, right?
Upload the soft copy. There are two methods. Uploading the soft copy means you can prepare that copy, one Word copy. Suppose I have one copy, in that all the details I fill it, I make it ready, I scan it and send it. You need not once again go on writing. As in case of name, USN, subject code, subject, I abide by the rules and signature. Those things, you keep on go on writing on the day of, you're already wasting some 5 to 10 minutes. That I'm saying.
Okay, sir.
Okay. Any other doubts you have?
Yes, sir.
So what about
Tell me.
I had a doubt that network at my home is not that stable where I can attend continuously with video on for 1 hour or so. It keeps logging out in between. What in that case?
In that case, I'll just inquire.
yes, sir, same question, sir.
I'll just inquire and let
Sir,
you know.
problem for all students, sir.
Yes, sir.
From D division, sir, we have like complaints from our classmates. Sir, I'm the CR of D division, sir.
Understood. No. What I'll just inquire. I'll just have a word with. I'll just put this word to HOD sir, and then I'll just let you know.
So in other colleges, they have made that directly they have to write and send it, sir.
No, I cannot comment on somebody else. Only what best can is what to this what solution can be found out. I can just let you know. So what I'll put up this thing, whatever your queries or doubts. I'll just put. I'll have a word just now with. I'll just go and speak with HOD sir, and they will have a discussion with them and proper authorities. And whatever communication is to be done, it will be put up by class coordinators to you within a day.
Okay,
I
sir.
hope. Yes. Okay.
Yes, sir.
Okay. Whatever your queries are there, that is regarding this net issues, I'll just have a word with sir and let you know.
Yes, sir. Yes, sir.
Okay. Apart from this, pertaining to subject or this, do you have any doubts?
No, sir.
So could we come to college and write the exam?
That only. Both the consideration, I'll just speak to sir and let you know. Both.
So if that would be, it would be much better, sir.
Just see, in case both things, I'll just speak with sir as well as HOD sir, and I'll let you know.
Okay. Okay, sir.
Okay.
Okay. Yes.
Okay. I'll just the same whatever queries are there, I'll just have a word with sir today, just now, and I'll let you know. Okay.
Yes, yes. Thank you, sir.
Apart from this, related to subject, do you have any doubts? Let me know. You can put it in the this classroom or this and get it clarified.
Yes, yes.
Okay. Thank you.
Thank you, sir.
Okay.